Today's topic 2, polymerization. Polymerization, based upon mode of preparation or mode of synthesis, we have two types: chain growth or addition polymerization, step growth or condensation polymerization. Addition polymerization, what is the internal meaning or definition for this? A polymer formed by the direct addition of repeated monomers without the elimination of byproduct molecule is called addition polymers. The polymer which is formed from the monomers by the direct addition without elimination of any byproduct, either water molecule, acid molecule, any byproduct. Such kind of addition is known as addition polymerization. Additional polymerization, which proceeds by three different mechanisms. One is free radical mechanism, second one cationic mechanism, and third one anionic mechanism. So under these three mechanisms, the addition polymer will be obtained. Each of the polymerization process proceeds in three steps. One is chain initiation, when you go for free radical mechanism, or when you go for in the cationic mechanism or anionic mechanism. Anyway, the polymer is forming. While the forming of polymers, which proceeds three steps, one is chain isomerism, chain initiation, chain propagation, and chain termination. So these three steps, finally you will get the addition polymer. As per our CBSE board, we have only free radical mechanism is there. The addition polymer is formed by free radical mechanism through three steps: chain initiation, chain propagation, chain termination. We will see one example what way the polymerization mechanism will proceed. Free radical mechanism. Free radical polymerization is initiated by organic peroxides. The free radical mechanism starts by few molecules which are organic peroxides or other reagents, which decomposes to give free radical. The following steps are involved. Step 1, chain initiation. Organic peroxides undergo homolytic fusion to form free radicals. Organic peroxides undergo homolytic fusion. Homolytic fusion means I am going to show you, for example, this is hydrogen, one of the molecule. This molecule is formed by the covalent bond. This covalent bond is equally divided into two parts, that is homolysis. The decomposition of covalent bond equally decomposed into two parts. This is homolytic fusion. This is the homolysis. During the homolytic fusion, you will get two free radicals. This is changed into H dot, this is changed into H dot. Like that, here the organic peroxides are C double bond O, 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 C double bond O here, and this is R. So this is O bond, O is peroxide bond. So this part is organic part, and this part also an organic part. That is the reason we know that inorganic peroxide O is attached with hydrogen and hydrogen. This is H2O2 inorganic peroxide. This is organic peroxide. So organic peroxide undergoes homolytic fusion. Here the decomposition is taking place, so that you will get the free radical. What way you are going to get free radical in chain initiation step, we will see. First step is chain initiation step. In this chain initiation step, you are getting two different type of free radicals. This is one free radical. This is C double bond O, one dot, and here R. So here the bond dissociation takes place. You are getting one. That is only I am showing in this case. R, C double bond O. Then the CO2 is removed. carbon dioxide is removed. And while during the homolysis, here you are getting one more free radical. So that is attached to this R. So plus R free radical. And along with that you are getting carbon dioxide. So in this way, in chain initiation, the organic peroxides undergoes homolytic fusion. You are getting a free radicals where R and here unstable acetate ion RCOO dot. So here this is the responsible for chain initiation, alkyl free radical. Step 1 is over. Step 2, chain propagation. Free radical adds to an alkene molecule to form a new free radical. So this is formed in chain initiation step. One free radical is formed, that is R dot. Plus actually our molecule is ethylene. CH2 double bond CH2. This is our molecule. This molecule reacts with this free radical. When this free radical, when you add it to, it means this peroxide, you add it to this ethylene, where this is undergoes decomposition and it is obtaining R free radical. This R free radical is reacts with ethylene. In this case, this bond is homolytic fusion, decomposed open, and one free radical is this free radical, and here too one more free radical is formed. This I am going to, for your better understand, like this: CH2 single bond CH2. So this free radical is coming here and another free radical is coming here. Now this free radical is attached with this one. During that the chain is increasing. R bond CH2 bond, here CH2, and one free radical is left. This is ready to involve with one more ethylene, CH2 double bond CH2. When chain opening takes place, here one free radical will form, the bond will be formed between these two. In this way, the chain will be propagate. Chain, inside the chain, the number of ethylene molecules come and join. This is the equation it will shows. R CH2 double bond CH2. In this CH2 double bond CH2, one bond is decomposed, two free radicals is obtained. One free radical is here and one free radical is come to here. So like that, R is attaching with this carbon, RCH2 and CH2. This is chain initiation and chain propagation. The free radical formed attacks another alkene molecule and the process continue in building a long chain. Like that, this process will continue in, we'll get a very big molecule. It will continue on and on. That is called chain propagation. And finally, see, third step, chain termination. The chain termination comes to halt when two free radicals chain is combined. See here, my dear students. Here what is happening? One is free radical and one is neutral molecule is adding. Neutral molecule means ethylene, CH2 double bond CH2. When you add the neutral molecule to this free radical, this neutral molecule is going to form two free radicals while decomposing this. Instead of this, when I add one more free radical, for example, R dot is there. Now I am adding one more R dot. What will happen while combining these two? R bond R will form. There is no bond is going to get again. So bond is closed. So to terminate, to close the chain, you have to add free radical. No need to add the neutral molecule. So that is the reason I am given a sentence in this case. The chain reaction comes to halt when two free radical chains combine. One free radical combined with another free radical chain, then the chain entirely closed like this. See here, this is the representation of chain termination. Many molecules are there, they combined each other, then you are getting R, CH2, CH2 taken N, CH2, CH2. For example, this is one molecule. Observe here, this is one molecule, sorry, one polymer, big chain polymer. and this is another big chain polymer, two chains. These two chains where this free radical electron is this one, this polymer electron is this one, this polymer electron is this one. It is having one free radical. It is having one free radical. Two free radical chains combined together will get a bond. So that there is no extra free radical is formed. The chain is closed. So in this way, chain termination takes place when two free radical chains combine together. This is the mechanism. In this way, the polymerization, addition polymerization will going on by three important stages: chain initiation, chain propagation, and chain termination. Now we'll see some important addition polymers, preparations, and their uses. Benzyl or tertiary butyl peroxides are common initiators, peroxides, and also used free radical polymerization can also be initiated by the mixture of ferrous sulfate and hydrogen peroxide. Along with the organic peroxides, this is also one of the compound to initiate a reagent, that is ferrous sulfate plus hydrogen peroxide mixture. We'll see important addition polymers and their preparations. Example for addition polymerization. Number 1, preparation of some important addition polymers by above method means free radical mechanism. One by one. First addition polymer we are going to explain you here, that is Ldpe. Addition polymer. Ldpe means low density polyethylene. L stands for low, D stands for density, P stands for poly, E stands for ethylene. Low density polyethylene is an example for addition polymer. So in what way it will be formed, I am going to show on the screen. C2H4 is a ethylene. So many molecules of ethylene combined together at atmosphere. Pressure is 1000 to 2000 atmospheric pressure. Trace quantity, a little supply of oxygen and heating in the presence of organic peroxide. It will give Ldpe, low density polyethylene. Low density means the density should be less. But polyethylene, how we can represent ma? N molecules of C2H4 undergoes polymerization in presence of organic peroxide. What you will get? C2H4, this curved lines you have to put like this under N. R, N, CH2, double bond, CH2, it gives, this is the polymerization process in presence of organic peroxide. You are getting CH2, single bond, CH2. Bond will be open. This bond will be open like this, taken N. This is polyethylene, polyethylene, and this is the monomer of ethylene. So N number of monomers involves in polymerization process in presence of organic peroxide. You are getting polyethylene. This polyethylene, when you use this experimental condition, you will get less density polyethylene. When you change the experimental conditions and reagent, you will get high density polyethylene. Let us see. Formula will be same. Only densities will be different. It is used in the insulation of electricity, carrying wires. Wires are covered with some plastic, that is called Ldpe. Different color wires, white color, different color wires. Wires insulated by here this Ldpe. Next one more addition polymer, that is HDPE polymer, high density polyethylene. High density polyethylene, low density polyethylene, the manufacturing process is same. But here we have to changing the catalyst, Ziegler-Natta catalyst. In presence of Ziegler-Natta catalyst, Ziegler-Natta means C2H5 taken 3Al plus titanium chloride, TiCl4. This mixture is known as Ziegler-Natta catalyst, very important point. In experimental condition, 333 to 343 Kelvin and 6 to 7 atmosphere, a little temperature, the ethylene is changed into polyethylene with high density, that is HDPE, polyethylene, high density polyethylene. One more, it is used for the manufacturing of buckets, dustbins, bottles, pipes. These are all HDPE polymers. Third example for addition polymer, third one is Teflon. The name of Teflon is polytetrafluoroethane. Polytetrafluoroethane. Poly means many, tetra means 4, 4 fluorines are there, ethene means 2. So Teflon is manufactured by heating tetrafluoroethane with a free radical or persulfate catalyst at high pressure. This Teflon is obtained from tetrafluoroethylene, free radical with persulfate catalyst. We'll see. See here, tetrafluoroethylene, tetra means 4 fluorines. Observe here, 4 fluorines are there. One carbon. Carbon involves in 4 bonds. See here, here one fluorine, here one fluorine, here one fluorine, and here one fluorine. So this is tetrafluoroethane. 4 fluorines are there. 1, 2, 3, 4. So 1, 2 tetrafluoroethene or ethylene. Like these molecules are how many involving? N number. Because we are going to form a polymer. So this process name is polymerization. Here we are using one catalyst, either high density or low density or Ziegler-Natta, like that catalyst and pressure. Then here are getting a Teflon. Teflon is a polymer, CF2, single bond is there, and which is right in the bracket. This is N. Tetrafluoroethylene changed into Teflon. It is chemically inert and resistant to attack by corrosive reagents. It is used in making oil seals, gaskets, and also used for non-stick surfaces. Teflon coating, you know, Teflon vessels you are using in your home also. Orlan, fourth addition polymer is Orlan or acrylan or polyacrylonitrile. These are the 3 different names: polyacrylonitrile, acrylan, and Orlan. Acrylonitrile, N number of monomers, nitrile means CN, cyanide. So ethylene molecule where one CH2 is, instead of one hydrogen, one cyanide is substituted. One cyanide is substituting here, CH2, 2 hydrogens, double bond, C, 1 hydrogen, and 1 bond is cyanide. Okay, instead of CH2, CHCN. These molecules are N, many molecules. This process is polymerization under organic peroxide catalyst. What will happen? This simple 1 bond is decomposed into a curved line. So then you are getting polyacrylonitrile. Poly means many acrylonitrile molecules. This is one acrylonitrile. One acrylonitrile monomer. This one monomer combined to give a many. That's the reason polyacrylonitrile. This is the polymer. Another name is Orlan. Next. Polyacrylonitrile is used as a substitute for wool in making commercial fibers as are iron or acrylan. So this is about addition polymers are over. Now we are going to see the second one, step growth polymerization or condensation polymerization. Condensation polymerization and addition polymerization. Addition polymerization, the two monomers, two or more than monomers combine directly without liberation of any byproduct. But in condensation polymerization, two different monomers direct combine to give a polymer with the liberation of byproduct. See the definition? Condensation polymers. A polymer formed by the condensation of two or more than two monomers with the elimination of simple molecule like water, ammonia, HCl, alcohol, etc. is called condensation polymers. So we'll see some examples in what way these condensation polymers are also prepared and their important uses. Step growth or condensation polymerization mechanism. Already we observed the addition polymerization mechanism following same three stages: initiation, propagation and termination. Here the step growth or condensation polymerization mechanism, what way it will form a polymer of condensed, we'll see. If the reactants in polymerization are bifunctional, they undergo series of condensation reaction in controlled stepwise manner with the elimination of small molecule like water, alcohol to form polymers, and the process is called condensation polymerization. Already I told you the definition, or the step growth polymerization. Condensation polymerization takes place between molecules having polyfunctional groups. Two molecules, two monomers. So each monomer having a polyfunctional group, for example, OH, CHO, OH, CH3COOH, Cl, COOH, like the two functional groups are there in one monomer. So condensation polymerization takes place between the molecules having polyfunctional groups. Generalization example I am giving the mechanism. A, one monomer, B is another monomer. These two are called as monomers, plural. Two different monomers combined together, you will get a big molecule, one molecule, that is a polymer. Here two monomers only involved to get one polymer. That polymer name is dimer. Two molecules are there, hence I am giving the name dimer. For example, we will take one more equation. AB is one molecule, A is another molecule. AB plus A undergoes condensation, you are getting ABA. Three molecules are present in this. So that this is three molecules are there, hence this is called as trimer. If a molecule which contains two different molecule, one big molecule contain two different molecule, that is dimer. One big molecule contain three molecules which are trimer, like the tetramer, polymer. See here, ABA, this is attaching with B, already trimer, it is a trimer, is going to taking one more monomer, tri is changed into tetra. Here di is changed into tri is changed into tetra, tetra is changed into penta, like that poly. Big molecule will be formed. In another hand, one more model, alternative steps for step growth proceed. A, one more choice is there, A plus B. Obviously, what product will you get? A bond B, one big molecule. Okay. AB, two AB type of molecules when combined. A plus B, you will get AB. One more A plus B, you will get AB. That AB, this AB, both ABs are combining. AB plus AB, you will get AB type of big molecule. This here only one AB is there. Again, one more AB is adding. One more AB is adding. A bond B is going to attach here. And when you add one more AB, what will happen? A bond B, it is going to attach here. When you add one more AB, that is going to go and add here. Like that, we will get a very big molecule polymers. So this is another process. Dimer, trimer. So here also same way. AB, AB, like that it is going to become a big molecule. This is the procedure to form mechanism to form a polymer, a step growth polymerization. So this is finally we can represent like this: AB, AB, AB plus AB, AB, AB. Different molecules all combined together. So N under the N. AB, all AB type are there. This is a polymer. This is about step growth polymerization mechanism. But this is the important we are going to learn. Right? We'll see one by one. Condensation polymerization, where what are the polymers? Example comes under this condensation polymers, and which monomer is there in that polymer. Example, all polyamides, polyamides, poly means many. Polyamides comes under example for condensation polymers. Example, polyamides, nylon 66, nylon 6 or perlon L. These two are the examples for polyamides. Polyamides are the examples for condensation polymers. Here nylon 66, how it will form? Every polymer is formed from the smallest units, which are called monomers. What is the monomer of nylon 66? That is hexamethylene diamine and adipic acid. Observe, my dear students, condensation polymer should have what happened? Two different monomers. Observe here, one is hexamethylene diamine, another one is adipic acid. In condensation polymers, two different monomers will be participate. One is hexamethylene diamine, another one is adipic acid. Next one, nylon 6, which is the monomer for this bit? Coprolactam. Coprolactam is the monomer of nylon 6. Polyesters is also example for condensation polymers. Polyesters. Under the polyester, example is Decron, polystyrene. The monomer is terephthalic acid and ethylene glycol. Terephthalic acid and ethylene glycol. Phenol formaldehyde polymer is also third example for condensation. This phenol formaldehyde polymer, under this bakelite will come. Why I am giving phenol formaldehyde polymer means, whatever I am giving example, the monomer is phenol formaldehyde. That is the reason these all polymers are phenol formaldehyde polymers, which contains monomer is phenol formaldehyde. So bakelite is an example for phenol formaldehyde polymer because the phenol and formaldehyde is the monomer. Malamine formaldehyde polymer, where malamine and formaldehyde is the monomers. Third one, thiol. Thiol, ethylene dichloro condenses with sodium polysulfide. These two, sodium polysulfide and ethylene dichloride, these are the monomers of this thiol. So these are the all examples for condensation polymerization or polymers. So how these will be prepared one by one, we'll see. Step growth polymerization or condensation polymerization, where we'll see the first one is polyamides, where the polymers possessing amide linkage, CONH linkage, are important synthetic fibers. They are made by condensation of diamine with dicarboxylic acid and also form amino acids or coprolactams. So amino acids, the cyclic amides, another name is coprolactam. Amine is different, amide is different. Amine means only NH2 is amine. CO with NH2 is that is amide. I will see. The preparation example for amides, polyamides. Polyamides are comes under condensation polymer. Polyamide example is nylon 66. It is made up of condensation of hexamethylene diamine and adipic acid, each of which possess 6 carbon atoms, and these numbers are represented in the name of product as 66. Acid and amine react to form amide. Here the polyamide is formed by heating. The reactant mixture under the pressure and process has been developed so that the molecular mass of polymer is controlled in the range of 12,000 to 20,000. So this is the formation of nylon 6. This is the structure of nylon 6. This is the reactants. One is the monomer. First monomer, what I told you, hexamethylene diamine. Hexamethylene means CH2s are 6 are there. CH2 6. This is called hexamethylene. Diamine, NH2 is amine. NH2 two amines are there. Hexamethylene diamine plus adipic acid. This is called adipic acid. Adipic acid formula CH2 taken for COOH, COOH. Okay. Instead of diamine, 2 COOH groups are there. Instead of hexamethylene, here tetramethylene is there. To form nylon 6. By combining these two, you are getting a nylon 6. How will you combine? Same simple adding. NH2 CH2 taken 6. NH. One H is you are removing. Why? You will get one byproduct. Then here HCO plus CH2 taken for CO. Isn't it? So here OH, here H, both removed as H2O2. That's the reason CO only there. Observe carefully, my dear students. Here OH is terminated now. Here H is one H is terminated. This H and OH, what will form? H2O. Remaining product is as it is attaching. NHCH2 taken 6, NHCO. See here NH, CO, CH2 taken 4, CH2 taken 4, CO and NH2CO taken N. So many molecules are forming here like that. That is the reason under the N they represented. So NH2CH2 taken 6 NH2. NH2CH2 taken 6. Here also NHCO CH2 taken 4 CO. Here hydrogen is removing. In this case hydroxide is removing, and that is formed as a H2O, and here one carbon monoxide, here one carbon monoxide, and here one CO is there, here also one CO is as it is, and H, here one oxygen, and here one hydrogen. Will get again one more H2O will be removed. In this way this process will be continued. This is the reaction of nylon 6,6. Next one, nylon 6, simple nylon 6 or Perlon L. It is formed by itself condensation of large number of molecules of amino caprolactic acids. This is the monomer is coprolactam. Coprolactam means what? Amide, polyamide. It is formed by itself condensation of large number of molecules of amino caproic acid. Since the caprolactam is more easily available, it is used for the polymerization, which is carried out in the presence of water that first hydrolyzes the lactam to amino acid. The amino group of amino acid can react with the lactam, and the process goes on and on to form polyamide, that is the polymer. This is the process. Whatever the given reactant is coprolactam. Actually, in all the cases, two different polymers, two different monomers combined together, you will get a polymer. Here only one component is involved, that is a special character here. that is caprolactam, undergoes hydrolysis, you are getting a nylon 6-perlon. Nylons are insoluble in common solvents, have a good strength and absorbs a little moisture. Polyesters. We have Decron is example. It is the best known of the polyester and is manufactured from ethylene glycol and terephthalic acid. The reaction is carried out 420 to 460 Kelvin in the presence of catalyst mixture, zinc acetate and antimony trioxide. So this is about the terylene preparation. It is obtained from two monomers, one is ethylene glycol, another one is terephthalic acid. The terylene fiber, that is another name is Decron, is crease resistant and has low moisture absorption. It has high tensile strength. It is mainly used in making wash and wear garments and blending with wool to provide the better crease and wrinkle resistance. This is about polyester. Polyester, many types are there. Under that, Decron is one of the polyester. One more, phenol or formaldehyde phenol, that is bakelite. Phenol means this one benzene ring is having OH, phenyl alcohol or phenol. This phenol is reacts with CH2O. You will get a polymer. So this is about the bakelite preparation. Here we are getting two different products. Here OH, this is CH2OH will be substituted here in ortho position. And again this process is continue. Here also we are adding one more CH2OH and meta position. These are the oldest synthetic polymers and are still extensively used. Phenol is condensed with formaldehyde in the presence of ether and acid or base. The reaction starts with an initial formation of oxygen and or parahydroxymethyl phenol derivatives, which further react with phenol to form compounds where the rings are joined to each other with CH2 groups. The initial product could be a linear product, that is Novalac, which is used in paints. See here, Novalac. So this type of formation will obtain in the first step. Phenol, when reacts with CH2O, you are getting either ortho substituted, next para substituted, then meta substituted, like that will be formed. This, after formation of this one, n number of these molecules combine together a big molecule, that is polymer. This polymer is phenol formaldehyde polymer or bakelite, where the first which will form, that is Novalac. This is the Novalac. Novalac after bakelite will form. See the complete structure of bakelite. On further heating with formaldehyde, Novalac undergoes cross-link to form infusible solid called bakelite. Yes, this is the bakelite. The first layer is Novalac. Again, one more Novalac is combined with cross-link with another polymer. You will get a big molecule. This is the structure of bakelite. This polymer called bakelite is hard, scratched and water resistant. It possesses excellent electrical insulating character and hence it finds major use in making electrical goods. Final one, Malamine formaldehyde polymer. Malamine formaldehyde polymer is formed by the condensation of polymerization of malamine and formaldehyde. This is malamine, this is formaldehyde, both combined together, you will get a resin intermediate. This resin intermediate is combining with this is a one monomer. Like this monomer, many will combine, you will get a malamine polymer. This is the malamine polymer under N. Lastly, thickol. Ethylene dichloro condenses with sodium polysulfide to give polymer called thickol. This polysulfide is example for rubber. This is the formation of thickol. So ethylene dichloride, CH2Cl, CH2Cl, this is the monomer. This reacts with sodium polysulfide. N number of molecules are there, that is the reason sodium polysulfide. This sodium polysulfide plus ethylene dichloride, both combined together, two different big chains combined together, you will get a polymer, condensed polymer, that is thickol, and byproduct is sodium chloride. So these are the few examples for condensation polymers and their preparations and important uses.